Recording started.
I know, right? So I'm on week 3, almost week 4 of this cough, and I just hope it leaves sometime soon because it's definitely overstayed its welcome. Um, so, with that being said, it is 9 o'clock, so we'll get started here this morning. So, just a few announcements to start us off today. Obviously, the major one is that this Sunday marks that final deadline, January 14th. Um, I think you guys, my pre-calc class, are kind of the best situated as far as missing work goes, in that there isn't very much missing work out there. So that's awesome news for you guys because that means that there's only, I think, 2 pieces of items left to turn in for the semester besides the final exam. One of those we're looking at today, which is the 5.06 lesson on the law of cosines. And correct me if I'm wrong, but I think you guys also have a Unit 5 test assigned for this week. Does that sound accurate? Okay, that's what I had thought. So you got those 2 things to do this week. And after that, then the only thing left is your final exam. Any major questions with that deadline or the final or anything? The plan of action is to look at the lesson today, 5.06. And then in Thursday's class, we'll go over final exam details. So Thursday will be shorter so that you can go ahead and take that Unit 5 test if you need to, or study for that, or get prepared for the final. On a scale of 1 to 10, how bad is this said final? It depends on how well you've done so far, I guess, in the course. I don't think it's that bad. I would probably give it around a 5. Um, I think as long as you study from your previous tests and homework assignments, you'll be just fine. All right. Sorry about that. Yeah, I don't really think it'll be too bad. In the past, because well, obviously I made the final brand new for you guys this year because the course is actually brand new. I just wrote it over the summer. So you guys are the first ones that are kind of taking this final, so we'll see how it goes. But in the past, there haven't been any major issues with the pre-calc stuff, so I think you guys will be okay. And again, as long as you just look at your previous tests and your homework assignments, that's a good tool to help you study for the final. It gives you a good idea of what to review and what's all going to be on that and all that kind of stuff. All right. Any other questions before we take a look at 5.06? 5.05 went amazingly well. I just like I thought it would because you're dealing with proportions, and proportions is nothing that's super complex. So, looking at the scores from 5.05, everyone did really well with that. So I was happy to see that. 5.06, I think you're going to like it just as much as 5.05. It's a little bit more difficult because we don't have proportions. We have formulas that we're looking at instead, but there's a pattern that you can pick up on with the formulas. So hopefully we won't think that 5.06 is too bad of a lesson either. Okay, so 5.06, which is the last lesson that we have to look at for semester 1, is on the law of cosines. So you probably could have guessed it because 5.05 was the law of sines. We are going to use the law of cosines to solve some of those other triangles. So law of sines, if we remember, we used it for, what is it, side angle, the ambiguous case, angle side angle, I want to say, and there was another case that we could use for the law of sines. For the law of cosines, we use it if we have side angle side. So usually we'll use that law of cosines if we have side angle side. We can also use it if we have side side side. So notice that they give you these three formulas for the law of cosines. They do deal with the three sides and an angle, but you can solve for the angle here, and you'll see these alternate forms below. And this alternate form is what you would use if you were given the side, side, side scenario. So if you have all three sides, you obviously want to use this alternate form to help you find for the missing angles that are given or that are there. All right, so taking a look at these formulas, can anybody pick up on a pattern to help you memorize these or remember them? So take a look. If you're trying to solve for side A, they use the formula a squared equals b squared plus c squared minus 2bc times cosine A. If you're trying to solve for side B, we use the formula b squared equals a squared plus c squared minus 2ac times cosine B. And lastly, if we're trying to solve for side C, it's c squared equals a squared plus b squared minus 2ab cosine C. Anybody see a pattern that we can try to use to memorize these formulas right here? Yeah, it's like, as long as you can kind of see it, let's see what we can get as far as descriptions go. B squared and c squared can be related to the 2bc, and a squared can relate to the angle that you're using. Good, so kind of the description we can apply here is the side we're trying to find. That's the angle we're using at the end, right? And then the other two sides, obviously you want to square them and add them together, and then subtract off 2 times the BC that you had already used. So if you can just remember the side that you're trying to find, that's the angle you want to use at the end. And then as far as the other sides go, you always start by squaring them and adding them together, and then subtracting 2 times those side lengths. Exactly. Good, Rebecca. All right, so as long as you can pick up on that pattern and try to remember that so that you don't have to keep looking back at your notes every single time, it might be beneficial to do that. But again, if you need your notes to look back on those formulas, definitely have them written down so that you can do that. Now, as far as the alternate forms go, there's a little bit of a pattern here as well. Notice the angle you're trying to find, that's what you're subtracting in the numerator as far as the side goes, right? So if you're trying to find angle A, you're going to subtract side A at the end squared. And then it's a b squared plus c squared over the 2bc there. So whatever angle you're trying to find, technically that's what you're subtracting at the end in your numerator. All right, go ahead, give me a green check mark once you have not only these three formulas copied down in your notes, but also the alternate forms as well, because you'll want these alternate forms to look back on. Well, we have a couple more students jotting those down. I just want to point out a few things as we venture forth and actually use these formulas. When we go to use these formulas and we have to find a side length or an angle measure, if we have to find a side length, don't forget we are using a squared here. So eventually at the very end, we're going to have to take the square root of all of this so that we can find just a, right? So at some point in our calculations, we will need to take the square root. Down here, if I'm searching for a missing angle, we're going to have to use the inverse, right? So at some point, we're going to have to use cosine inverse of some decimal form to find the actual angle measurement. So even though these formulas are great, there is a little bit of extra work needed to find the missing side or the missing angle than what's here. All right, let's take a look at an example. So again, I already kind of mentioned we can use the law of cosines for side angle side or side side side. So essentially the side angle side, the easiest to recognize is you have two sides and then that third angle that's the letter that isn't given yet, right? So A, B, and C, you need a form of those for the three measurements that you have. So two of them will be sides, the third one's an angle, but you need one letter of each. All right, so let's go ahead and looking at the information that's given in example 1 here, which missing piece do you want to try to solve for? We can solve for side C, angle A, or angle B. Those are the three missing things here. So what do you guys want to solve first? Side C. Okay, that's generally what I would lean towards as well, is that third side. Not that it's unnecessarily easier, but this kind of just what sticks out the most. All right, so for looking for side C, remember we're going to use the formula C squared equals A squared plus B squared minus 2AB times cosine of angle C. So the most important thing as I substitute in here is making sure that we are plugging things in correctly to the calculator. The other thing we want to make sure is that we're in the correct mode. Because you're dealing with degrees, just make sure real quickly that your calculator is in degree mode and not radian. All right, so let's go ahead and punch those in. Let me know what you get once you typed all those in. So here's what my calculator looks like, just in case you're wondering. All right, so I got the same thing there, but this is not our answer because this is what C squared equals. So don't forget now after we get this, we have to take the square root of it. So go ahead and take the square root of that answer. And we'll go ahead and type that in there, a 6.539, and it is a plus or minus there, but we got to use the plus because it doesn't make sense to have a negative side length, right? So 6.53 or 29 we'll go with for side C. Awesome. All right, so then the next piece are the two missing angles. So do you want to find angle A or angle B? Angle A. Awesome. Okay, so cosine of A That means I need to be using B and C, right, for my two sides here. So B and C, and then minus the A, all over 2 times B times C. Now be careful as you type this into your calculator. We'll probably want to put additional parentheses around the numerator and the denominator just to make sure our calculator is doing the order of operations correctly. So here's how I type that in case anybody is wondering. All right, I'm seeing some chat bubbles light up. So let's see what we get there. A negative 0.817. And then I bet Isaias did the cosine inverse. So let's go ahead and do cosine inverse of that negative 0.817 for 629,959. 144.83. So angle A is 144.83 degrees. All right, the good news is that once we find one of the missing angles, we do not need to use another cosine formula to find the third. What can we do to find the third missing angle now? Sorry. Yeah, just subtract from 180. So that's the nice thing about those angle measurements is you probably only have to use a formula one time because then you can just subtract to find the third. So minus 20 minus 144.83. That will help us find angle B, which is 15.17 degrees. Okay. Good. So not so bad, right? Any questions with that first example? Man. Is there a cure? More math. All right, let's go ahead and take a look at not the cure you were looking for. Oh, bummer. All right, let's take a look at another scenario. Here you have the three side lengths. So side, side, side. We have to use those alternate forms to find the missing angles. Unfortunately, this time, because we do have all three sides and we're missing all three angles, we do have to use the alternate forms twice. So that we can at least find two of the angles before we can subtract from the 180. All right, so I'll leave it up to you guys. Which angle would you like to solve for first? And there's no right or wrong answer. A, all right, A has it. That's the popular choice. So cosine of A. So using that formula, we need to start with B and C. So B squared plus C squared minus A squared all over 2 times B times C. You've been voted off the island. All right, again, just make sure as you type this in, you're putting parentheses around the numerator and denominator. Go ahead and work this one through. Make sure that you do cosine inverse for that last step of whatever decimal you get there. And let's see if we can all come up with the same degree measure for angle A. You guys are fast. I'm still looking down at my calculator here, and I look up and the answers are already there. 95.739, 95.74, however you'd like to round that is fine, but we do get that answer for angle A. What's the next angle you would like to look at? We'll take popular vote this time. I knew that you were going to throw C in there. We need a tiebreaker, B or C. All right, so we'll find angle C next. So cosine of C. And if you want to be a rebel and find B using the cosine formula here, you definitely can. So let's see. If we're finding angle C, that means we have to start with sides A and B. So A plus B squared minus C squared all over 2 times A times B. Okay, so remembering my pattern there, if I'm finding C, I've got to subtract the C squared at the end, and I do the AB up front. All right, let's go ahead, punch her in, see what we get. Fantastic, that's what I get as well. And now we just have subtraction to find that missing angle. So to find angle B, let's go ahead and subtract from 180. And what do we get there? A 50.704. Fantastic. Any questions with those? That's a good question. Well, I know that it was more of a joke that Isaias had thrown out there. But can we get an error message when we're trying to solve with the law of cosines? Do you think that's a possibility? Like we had with the law of sines? Yeah, it is. Now, generally, that's going to happen when you're given the 3 side lengths. And your 3 side lengths technically can't form a triangle. So remember those rules and properties from geometry that we had with our sides of a triangle and when we can form them? Remember, we need to look at the 2 smaller sides. And if the 2 smaller sides added together is not larger than the third, a triangle cannot be formed, right? So in this case, our 2 smaller sides are 5 and 7. If we were to add 5 and 7 together, and that is not larger than the third side, which is 9, you cannot form a triangle. In this case, 7 plus 5 is 12. 12 is larger than 9, therefore the triangle can be formed. But if those two smaller sides were not, then technically that triangle cannot be formed and you cannot find any missing pieces to it, right? So that is something that we've got to keep an eye out for. And if we don't recognize that, we would most likely run into errors with our formulas. All right, we got two more formulas for you today, and they have to do with finding the area of a formula. Area of a formula, area of a triangle, sorry. So the first thing that we're going to look at is if we have the side, angle, side. If you're given side, angle, side, we're going to go ahead and use one of these formulas to help us find the area of the triangle. So 1/2 times the two side lengths times sine of the angle between them. Okay, and it always follows that pattern. 1/2 times the two side lengths times sine of the angle between it. So no matter what you're given, it will follow that format. All right, let's go ahead and take a look at an example. So this is for side, angle, side. We will have a different formula for side, side, side in just a moment. So this is the formula we use for side, angle, side. It says find the area of a regular octagon which has 8 equal sides and 8 equal angles inscribed inside a circle of radius 9 inches. So essentially what we're going to do is we're going to find the area of this little triangle and then multiply that by 8, right? Because there's technically 8 different triangles identical to that in this octagon. So if we can find the area of just one of the triangles, we can use multiplication to find the area of the entire octagon. All right, but in order to go ahead and use one of these formulas listed above here, we've got the two sides of 9 and 9, but we need that angle in between it. How can I find this angle measurement in the middle here if I know that this is a regular octagon? 360 divided by 8, exactly. Yep, so what is 360 divided by 8? So what is that angle in the middle there? 45. Yeah, keep it simple. So 360 comes from the full circle that you can create with all 8 angles. And if you've got a full circle in the middle there, that's your 360. You're dividing that into 8 equal pieces. 360 divided by 8 means that each piece is going to be 45 degrees. All right, so exactly. So let's go ahead and take a look at using our formula then. So the area for one of those triangles in yellow would be 1/2 times the side lengths of 9 and 9 times the sine of the angle in the middle, which is your 45 degrees. So let's just start there. What is the area of one of the triangles in there? $28.638. Can anybody second that? Rebecca's going to second that. Isaias is going to third it. All right, that's just one of the yellow triangles. If we are looking for the area of the entire octagon, we've got to multiply that by 8, right? Because there are 8 triangles in that octagon. So what is the total area of the octagon inscribed inside that circle? a 229.103.105. It should be a 0.103, I think is, yeah, there you go. That was just a typo because it was 0.1025. So that would round it up to a 0.103. Good. Or a 0.10 if you're rounding it to the nearest hundredth. All right, questions. And I probably should put inches squared on that, right? Units of measure are important. Since we're talking about area, it's going to be squared, and it does look like it's given in inches there. Any questions with that first area formula? And again, we use this one if we are presented with side, angle, side. If we're presented with side, 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 then we have to use a different formula. We're going to use something called Heron's formula. And Heron's formula is a little bit more complex. I'm not expecting you to memorize all of this, but this is how his formula was derived. So if you're interested, you can see the full proof here of how he came up with it. But basically, you have to find an additional piece of information called the semi-perimeter. The semi-perimeter is denoted with a little s. I know, right? I wouldn't have the time to sit down and do all this. Apparently, they had a lot more time on their hands back in the day. So to find the semi-perimeter, which they denote with the lowercase s, basically you're going to add the three sides together and divide by 2, which is a little bit strange because that kind of wants to spark like an average. We think of average when we divide there, but it's not an average. It's dividing by 2, not 3. So we just want to make sure that we're not taking the average by mistake when we're trying to find that semi-perimeter. Okay, once you find the semi-perimeter of S, basically the formula then comes down to the square root of S and then everything subtracted from that. So all the sides subtracted from S there. So S minus A, S minus B, and S minus C. Again, we're not going to go over exactly every single step here on how he got that formula. It is quite interesting once you look at it, but knowing that the formula can be used to find the area is what we're going to go with. Any questions with this? Everybody got it written down so that we can take a look at an example? Okay, awesome. All right, so if we're presented with side, 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 we can go ahead and find the area by first finding that semi-perimeter. So we've got to calculate S before we can go any further with the formula. So to find S, let's add all three sides together and divide by 2. So what is the semi-perimeter going to be for this triangle? $23. Anybody going to second the 23? Isaias is. And Rachel's going to third it. Awesome. So once we have that 23, we can go ahead and set up our formula. So we'll take the square root of that 23 times. Now let's subtract everything from that 23. So we're going to start with subtracting the 13. We'll subtract the 15. And we'll subtract the 18. You should not get any negative numbers when you subtract here because you did divide by 2 instead of divide by 3. So that semi-perimeter should be the largest value and larger than your 3 sides. All right, so I'm sure that you guys, as I'm talking here, are already diligently plugging this into your calculator. Let me know what you get when you punch this all in. about a 95.92, 95.917, depending on where you're going to round that to. We don't have a units of measure here, it doesn't look like, so we're just going to do units squared so that we know that measurement is an area for something. Good. Any questions with this example? All right, guys, believe it or not, there's nothing new to add to semester one. So with Heron's formula there, we've wrapped up all the stuff we needed for semester one. I still have a few practice problems, but I thought that was a pretty important thing to point out there, that everything at this point is all review. So nothing new will be presented after this for semester one. All right, so we do have time to practice a few more questions. I know, it's a pretty big task we just completed there. Let's go ahead and take a look at this one and solve the triangle. Everything's downhill from here. All right, let's go ahead. We have the three sides, so side, side, side. Looks like we're missing the three angle measurements. So it's up to you guys which angles you want to solve for first. No right or wrong answer here. Whatever, we'll just take popular vote again. So what angles do you want to start with? B. We got to vote for B this time. B is the best angle to go for. Well, since we don't have any altering votes there, we'll go ahead and find angle B. So again, remember we got to use that alternate form because we are looking for angle measurements, so cosine B. If we're starting with angle B, that means we've got to set it up with sides A and C to begin with. So A squared plus C squared minus B squared all over 2 times A times C. Okay, lots of decimals, lots of multiplication there, so make sure we don't confuse what's a decimal point and what's a multiplication notation. All right, go ahead, work it through. What do you get for angle B? I did get 99.216 as well. So we'll go with that one. Just double check, maybe there was a little bit of a typo with one of the decimal points or something extra got added in by accident. Your answer's not that far off though, so it had to have been a typo or something along the way. Or maybe did you round a little bit when you did your cosine inverse? If you rounded a little bit, that's why. So your answer is still acceptable because you rounded when you did your cosine inverse of that decimal number. So that's what happened there. Okay, and that's okay. It's still close enough that you'll have the right value. We found angle B. Anybody have an opinion on what we should search for next, A or C? A it is, okay. We agree with A. It's the first time we agree, I think, right? So if we're starting for angle A, we've got to do B and C. So side B squared plus side C squared minus the A squared all over 2 times B times C. All right, I'll let you guys work this one through now. 24.558 or 24.56, depending how you're going to round that. Looks good to me. That means for angle C, we do not need to use a formula. We can use subtraction to find that. What will angle C equal? Woohoo! Oh, gotta get it centered. There we go. 56.226 degrees. Beautiful. Questions with using the law of cosines to help you solve that triangle. All right, find the area. So what setup do we have? Do we have side, angle, side, or do we have side, side, side? Because that's going to determine which area formula we want to use. So what do we got going on here? We've got side, angle, side, right? We see the angle there, so obviously that's a key one. So the formula we're going to do is 1/2 times the side lengths. So the side lengths, it looks like, are 32 and 19. And we're going to multiply that by the sine of the angle between them, which is your 47 degrees. All right, so let's just punch her in. This is a nice formula compared to Heron's formula. Two 2.33 2, if you want to add another one on, sure, feet squared. Awesome. Questions with that one? We are just flying through them now. I told you guys would like the law of sines and the law of cosines lessons. We'll end on a high note. All right, decide. Don't make me laugh. That's when the coughing starts. Okay. Sorry. Decide whether a triangle can be formed with the given side lengths. If it can, use Heron's formula to find the area of the triangle. So here is that geometry property that we talked about with being able to form a triangle given the 3 side lengths. Can we form a triangle? Right, to answer Isaiah's question and mine, no, right? In this case, laughter is not the best medicine for me. And no, we cannot form a triangle. Why can we not form a triangle? Yep, because when you add the 2 smaller sides, it equals the third. And we have to know that it's got to be larger than the third. So because it equals it, we cannot actually form a triangle here. So because the triangle cannot be formed, we cannot use Heron's formula because obviously there's no triangle to find the area of. Yeah, whatever is the longest length. So basically you just got to look at those 2 smaller sides, add them together, and it's got to be larger than the third. All right, beautiful. Good way to wrap up the last lesson of the semester. So now you can use the law of cosines to solve triangles where you have side, angle, side, or side, side, side. And then you can go ahead and actually find the area of these 2 types of triangles as well, if the triangle can be formed using one of those formulas. All right, guys, that's all I got for you today. So if run through that one and what we'll do in Thursday's class then. So we'll still have class on Thursday. I'll start off with any questions you had regarding the lesson or anything in Unit 5. and then we'll go over the final exam details. So Thursday's class might be a little bit shorter, depending on how many questions you guys come with for the start there. All right, that's all I got. So you guys have a fantastic Tuesday, and I'll see you all Thursday again. Bye, everyone.